A monopoly is the sole supplier of a good for which there is no close substitute. It arises when a single firm owns a key resource of production, or when the government gives a firm the exclusive right to produce a good, usually in the form of patent or copyright. Another possible reason for a monopoly to arise is that a single firm enjoys strong economies of scale, meaning that it can supply the entire market at a lower cost than many firms could. In short, the main cause of monopolies is barriers to entry, which other firms cannot enter the market. The demand a monopoly faces is the market demand, which is downward sloping in general. This downward sloping demand curve constrains the monopolist's ability to price its products. When it sets a higher price, it will sell less. In other words, the monopoly firm is facing a trade-off between price it can charge and output it can sell. As a general rule, the monopoly firm will consider the marginal revenue and marginal cost to maximize profit. In the following, we will look at the pricing and output decision of this monopoly firm. Let's start with the market demand. It will be easier for us to consider an inverse demand function in which P is expressed as the function of Q. Suppose we have a linear demand curve of the form P equals 24 minus Q, where P is the price and Q is the quantity or output of the monopoly firm. You can see that first, the y-intercept is 24, and second, the slope of the inverse demand is -1, implying a downward sloping straight line. The total revenue is P times Q. As you can see, we can express the total revenue as a function of Q, as the market price P is dependent on Q. We can find the marginal revenue by differentiating TR with respect to Q. MR equals DTR over DQ. The total revenue can be expressed as TR equals P times Q. Given that the market demand is P equals 24 minus Q, we can substitute the expression of P into the total revenue, or TR function, and that gives us TR equals 24 minus Q, then multiplied by Q. Simplifying the expression gives us TR equals 24Q minus Q squared. And so the marginal revenue is MR equals DTR over DQ, which is 24 minus 2Q. Let's take a closer look at the marginal revenue function. Marginal revenue equals 24 minus 2Q. The y-intercept is 24, while the slope is -2. Graphically, it will look like this. Demand is P equals 24 minus Q. Marginal revenue is 24 minus 2Q. By comparing the demand and marginal revenue functions, we can see that first, they share the common y-intercept. Second, the slope of marginal revenue is twice that of the inverse demand. And graphically, it will look like this. What you can see here is that the marginal revenue of a monopoly is always below price. Up to here, we have found the marginal revenue of the monopoly firm, which represents the marginal benefit of producing an additional unit of output. Let's now turn our focus to the cost side. For simplicity, let's assume the monopoly firm has the following total cost function. TC equals 12 plus Q squared. $12 represents the fixed cost, which is part of the cost that doesn't change with the output level. Part of the cost function that changes with the output level is Q squared, which is the variable cost. On the other hand, the marginal cost is the additional cost of production that the monopolist has to incur if it produces one more unit of output. It can be found by differentiating the total cost function with respect to Q. MC equals DTC over DQ. MC equals DTC over DQ, which is equals to 2Q, which is increasing in Q. So graphically, it looks like this. As mentioned earlier, the monopoly firm can maximize profit by equating the marginal revenue and marginal cost. That is, marginal revenue equals marginal cost. 24 minus 2Q equals 2Q. Thus, Q equals 6. It means by maximal profit can be earned when the monopoly firm produces 6 units of output. We usually denote this profit maximizing level of output by Q star. When looking at the inverse demand curve, we have PQ equals 24 minus Q. By substituting Q equals 6, we have P equals 18. That is, the profit maximizing price for the firm is P equals $18. Given the market price and the output level, we can find the firm's total revenue, total cost, as well as the level of profit. Total revenue equals P times Q, which is $18 times 6, which gives us $108. Total cost is 12 plus Q squared, which is $12 plus 6 squared, which gives us $48. Profit equals $108 minus $48, which gives us $60. This numerical result can be expressed by a diagram. As we can see at the panel on the top, MR equates MC at Q equals 6, represented by point A. At Q equals 6, the firm will charge $18, which is the maximum price that consumers are willing to pay. At the panel on the bottom shows the level of profit and revenue for different level of output. As shown, the level of profit is at the maximum when Q equals 6. Another way to a firm to maximize its profit is to look at margin, which is computed by price minus marginal cost over price, and the inverse price elasticity of demand 1 over absolute value price elasticity of demand. The monopoly's firm profit will be maximized when price minus marginal cost over price equals 1 over absolute value elasticity of demand. Recall the inverse demand is P equals 24 minus Q. By rearranging the terms, we can find that the demand function is Q equals 24 minus P. The price of elasticity of demand can be found by E equals dQ over dP times P over Q. And so with our demand function, we have -1 times P over 24 minus P. On the other end, we have MC equals 2Q. We can express it in terms of P. MC equals 2Q equals 2 times 24 minus P, which is equals to 48 minus 2P. Plugging the MC and price elasticity E into the equation, we have P minus MC over P equals 1 over absolute value of E. P minus 48 plus 2P over P equals 1 over P over 24 minus P. Simplifying the expression, we have 3P minus 48 over P equals 24 minus P over P. 3P minus 48 equals 24 minus P. Thus, P equals 18, Q equals 24 minus 18 equals 6. We have the same result as before. The simple numerical example reminds us that the two rules for profit maximization are MR equals MC, P minus MC over P equals 1 over absolute value of E, which are both equivalent. Both suggest that a monopoly firm should consider both demand conditions and production costs when finding the profit maximizing price and quantity.